let us go for a new topic, atomic structure. Okay. Now, first of all, what is atom? You know, atom is a Greek word. I mean, it has actually come from a Greek word, atomio. The meaning of this word, atomio, is uncuttable. Or non-divisible. Okay. So in earlier days, scientists thought that atom is the ultimate particle of matter, which cannot be further divided. That was the thought that scientists had earlier. You know, the first theory that was proposed about atom was by John Dalton. He proposed Dalton's atomic theory. According to this theory, atom was considered to be the ultimate particle of matter. Ultimate particle in the sense which cannot be further divided, or the smallest particle of matter. Later on, of course, different scientists made some other experimental observations and found that atom can be further subdivided. Into three different types of subatomic particles are fundamental particles. Okay. Now the three subatomic particles are the fundamental particles of atom are electron, proton, and then neutron. Okay. Of course, there are many other particles inside the atom, but these are the important subatomic particles. Okay. Let us discuss in detail about these three subatomic or fundamental particles. First of all, let me discuss in detail about electron. You know, electron was discovered by Thomson. Okay. The name electron was given by G.J. Stoney. It was discovered by J.J. Thomson, but the name electron was given by G.J. Stoney. Now, coming to the data of electron, let us first see the charge, mass, and specific charge of electron. First of all, the charge on electron. The electrons carry unit negative charge. Okay. Coming to the magnitude of charge, let me give it as 1.602 into 10 power minus 19 coulomb. This is in coulombs. Okay. It can also be given in electrostatic unit as 4.802 into 10 power minus 10. ESU stands for electrostatic unit. Okay. This is in coulomb. This is in electrostatic unit. And this is the charge carried by one electron. Okay. Of course, this minus refers to the negative charge that electron carries. It's not minus 1.602 into 10 power minus 19. Only thing is the minus sign what I have written refers to the charge that they normally carry. The magnitude of charge is 1.602 into 10 power minus 19 coulombs, or 4.802 into 10 power minus 10 ES. Now let us calculate the charge on 1 mole of electron. Okay. You know, mole refers to Avogadro number of particles. Amount of substance that contains Avogadro number of particles. What do you mean by Avogadro number? Of course, it is given as 6.022, or let us take 23 into 10 power 20. Okay, so this is Avogadro number. Amount of substance that contains Avogadro number of particles. The particles include atoms, molecules, or ions. Okay. Now, coming to the charge carried by 1 mole of electrons. Come on. We know that the charge carried by 1 electron is 1.602 into 10 power minus 19 coulomb. This is the charge of 1 electron. If you want for 1 mole of electron, multiply the charge carried by 1 electron by Avogadro number. This is the charge carried by 1 electron multiplied by Avogadro number. Okay. Now, this comes out to be 96,500 coulombs, or you can also say 1 Faraday. Okay. This is the charge carried by 1 mole of electron, right? Next. Now let us go for mass. Mass of 1 electron. Of course, electrons have a negligible mass, very less mass. Let me give you the value. You know, it can be given as 9.109 into 10 power minus 28 gram. The same thing can be written as 9.109 into 10 power minus 31 kg. Okay, this is in grams, this is in kg. Isn't it? 1 gram multiplied by 10 power minus 3 will give you the mass in kg, because 1 gram is equal to 10 power minus 3 kg, or 1 kg is equal to 10 power 3 gram, right? Now the same thing can be given as 0.3058 AMU. Now this is very interesting. You know, this is called atomic mass unit. Nowadays, this AMU is represented by U. U refers to unified mass. Now, whatever it may be, the atomic mass unit or the unified mass, you know, it actually refers to 1/12 of mass of 1 atom of carbon 12. This can be given as 1/12 into, you know, the mass of 1 atom of carbon can be given as 12 by Avogadro number. Let me tell you how. You know, the mass of N, nothing but Avogadro number of atoms of carbon can be given as 12 grams. This 12 grams is the mass of Avogadro number of atoms. And we wanted the mass of just 1 atom. This will be, of course, 12 by N, isn't it? 1 into 12 by N. That is what I've written. So for Avogadro number of atoms, the mass is 12 grams. For 1 gram, it is how much? It can be given as 12 by N, isn't it? Now, this can simply be written as 12 get cancelled. And say this can be given as 1 by Avogadro number. Now 1 by Avogadro number, or 1 by 6.023 into 10 power 23 can be given as 1.66 into 10 power minus 24 gram. Or the same thing can be written as 1.66 into 10 power minus 27 kilogram. Check this out. So this is an important discussion. Atomic mass unit are AMU, nothing but U. Our unified mass can be given as 1/12 of the mass of one atom of carbon 12. Okay. So on simplification, this is what we get. 1.66 into 10 power minus 24 gram, or 1.66 into 10 power minus 27 kilogram. Okay. Now, let us go for the mass of 1 mole of electron. Okay. Now, we know that the mass of one electron is 9.109 into 10 power minus 28 grams. This multiplied by 1 mole, nothing but 6.023 into 10 power 23. Okay. Now, this can be written as 0.55 into 10 power minus 3 grams. Say this 10 power minus 3 grams can be written as milligram. This is about the mass of 1 mole of electron. Now let us go for specific charge. You know, specific charge is nothing but electrical charge by mass. We have discussed both the things. Right at the beginning, we have discussed the charge or electric charge. And now, of course, we have also discussed the mass. Now let us take the ratio of both. Specific charge can be given as electrical charge by mass. Electrical charge E by mass is M. This is what we call E by M ratio. Now, see, I gave you charge in coulombs as well as the ESU. Even in case of mass also, of course, I've given it in grams as well as kilograms. Right. Now let us give specific charge in 4 different units. Coulombs per gram, coulombs per kg, ESU per gram, then ESU per kg. Okay. Let us see them all one by one. Now, if you consider charge in coulomb, what is that? 1.602 into 10 power minus 19 coulomb. The mass in grams is this. Okay. This will give you 1.759 into 10 power 8 coulombs per gram. Now let us keep the charge as it is and take the mass in kg. Now this can be given as very simple. Same into 10 power 11 coulombs per kg. So we got the specific charge in coulombs per gram. Of course, in coulombs per kg also. Now, let us take the charge in ESU now. What is that? 4.802 into 10 power minus 10 is the charge in ESU, and the mass in gram 9.109 into 10 power minus 28. See, this comes out to be, you need to remember these values or else you have to simplify, but simplification takes too much time. So try to remember these things. So this comes out to be 5.28 into 10 power 17 ESU per gram. Now let us keep the charge as it is. Mass, let us consider in kilograms. Now this comes out as 5.28 into 10 power 20 ESU per kg. Okay. So this is all about the data of electron. I've given you charge on 1 electron, the charge of 1 mole of electrons, then the mass of 1 electron, the mass of 1 mole of electrons, and finally specific charge in different units. Okay. Now let us go for the data of proton. The protons were discovered by Rutherford, who of course discovered the nucleus. Okay. Now, see when a nitrogen nucleus is bombarded with alpha particle, nothing but this helium nucleus. You know, you get O817 isotope. The mass number of oxygen is actually 16. Of course, there is 17 also. So we call this the isotope of oxygen. Along with that, you get this. This is what we call proton. Okay. So that is how nitrogen was discovered by, proton was discovered by Rutherford by bombarding nitrogen nucleus with an alpha particle. Now let us go for the data of proton. The first one is again the charge. Charge on 1 proton. Of course, the magnitude of charge on both electron and proton is same, but protons carry unit positive charge. The magnitude is same, 1.602 into 10 power minus 19 coulomb, or 4.802 into 10 power minus a 10 ESQ. Right? This is in coulombs. This is in electrostatic units. Okay. Now let us take the charge carried by 1 mole of proton. Same. Charge on 1 mole of proton can be given as the charge on 1 electron multiplied by, charge on 1 proton multiplied by Avogadro number. The charge on 1 proton can be given as this in coulombs multiplied by Avogadro number is this. So this can be given as the same 96,500 coulombs or 1 Faraday. So this is the charge carried by 1 mole of proton. Then next, it is the mass. Mass of 1 proton first. Now coming to the mass of 1 proton, it can be given as 1.6726 into 10 power minus 24 gram. You can give it as 1.67 or 1.67262 into 10 power minus 27 kg. Okay. Now the same thing in AMU. It can be given as 1.007825 AMU. You know the mass of proton can of course be given as 1836 times to that of electron. You can check this out. When you multiply the mass of 1 electron by 1836 times, you get this. So the mass of 1 proton is 1836 times to that of electron. Now let us take the mass of one mole of a proton. Very simple. It is nothing but the mass of 1 proton multiplied by Avogadro number. So this can be given as 1.0074 gram. Okay. This is the mass of 1 proton multiplied by Avogadro number. Nothing but 1 mole. Right. Now let us go for the specific charge of proton. Nothing but E by M again. Electrical charge by mass or simply charge by mass. It can of course be given in 4 different units. Charge in coulombs. Come on. by mass in grams, that is 1.67262 into 10 power minus 24 gram. So this can of course be given as almost equal to 10 power 5 coulombs per gram. Of course, 9.58, which is almost the same as almost equal to 10. So this is in coulombs per gram. Let us keep the charge in coulomb. But let us take the mass in kg. So this can be given as 9.58 into 10 power 7 coulombs per kg. Okay, let us also give the specific charge in ESU per gram and ESU per kg. The charge in ESU is this by mass in gram. This can be given as 2.87 into 10 power 14 ESU per gram. Keep the charge as it is. And take the mass in kg, of course. So this can be given as 2.87 into 10 power 17 ESU per kg. So this is all about the data of proton. I've given you the charge on one proton, the charge on 1 mole of protons, then the mass of one proton, the mass of 1 mole of protons, and finally the specific charge in 4 different units. Okay. Now let us go for neutron. You know, neutrons were discovered by James Chadwick. They were discovered by Chadwick. Even beryllium nuclide. In general, in nuclear chemistry, atoms are called nuclide. So when beryllium nuclide is bombarded with an alpha particle, you get a carbon nuclide along with a neutron. So this is your neutron. This refers to charge and this refers to mass. Let us just recall electron and proton also. Now this is electron, right? Whatever is written as a subscript, this refers to the charge. You know, this is of course unit negative charge. And as I said, the mass of electron is almost negligible. 0.305448 AMU. Okay, so this is all about electron. Come on, let us go for proton also. Just now I gave. So this is proton. Coming to proton, you know, protons carry unit positive charge. And of course, unit mass. Okay. Unit mass, unit positive. And coming to neutron, they carry no charge at all. Let me say that they are neutral. Okay, let us straight away go for the data of neutron. First of all, the charge. As I said, neutrons are neutral, nothing but chargeless, isn't it? They have got zero charge. So there is no question of charge on 1 mole of neutrons, right? Because they have got no charge at all. They are neutral or chargeless. Let us go for the mass. Mass of one neutron. You know, the mass of one neutron can be given as 1.67493 into 10 power minus 24 grams, or 1.67493 into 10 power minus 27 kg. Okay. Now the same thing in AMU. It can be given as 1.008665 AMU. Okay. Slightly more when compared to that of proton. I hope you remember that the mass of proton is 1.007276 AMU. That means the mass of neutron is slightly more than that of proton. Okay. You can also say that it is 1840 times to that of electron. This is the mass of proton. If you want, you can also give the mass of hydrogen atom. You know, the mass of hydrogen can be given as 1.007825. Hydrogen, in the sense, it will have a 1 proton and 1 electron. I mean for protium. So this is all about the mass of neutron. Very important. Mass of proton is 1836 times to that of electron, whereas the mass of neutron is 1840 times to that of electron. Okay. Now let us go for the mass of 1 mole of neutrons. What is the mass of 1 mole of neutron? Come on, this is the mass of 1 neutron multiplied by Avogadro number. This is, of course, 1.0088 gram. The mass of 1 mole of protons was 1.0074 gram. Now this is 1.0088 gram, slightly more, right? Now the last one. The specific charge of neutron. You know, the specific charge can be given by, of course, electrical charge or simply charge by mass. We know that neutrons are chargeless or have got zero charge. So charge is the zero. Of course, they have got some mass. But 0 by something is what? 0. So the specific charge of neutron is, of course, 0. Right. Now, let us just go for some important points regarding the fundamental particles or subatomic particles. You know, mass of electron moving with a velocity v, that is mv, can be given by mv is equal to m naught, nothing but the rest mass of electron. That means when it is not in motion. So this can be given as mv is equal to m naught by under root 1 minus v by c whole square, where you know this m naught is the rest mass of electron. V is the velocity with which it is traveling. C, of course, is the velocity of light. Right. This is the velocity with which electron is traveling. Now let us consider a condition. If suppose V is equal to C, I mean if electron is traveling with a velocity equal to the velocity of light, what happens? You know, when V becomes equal to C, this will become 1. 1 minus 1 is a 0. Something by 0 is infinite, isn't it? Then mass of electron moving with a velocity v will become infinite. So this is a very important relation. The mass of electron moving with a velocity v can be given by mv is equal to m naught by under root 1 minus v by c whole square. Okay. One more interesting point. Generally, when, I mean, we know that specific charge is charge by mass, right? Let us check the effect of increase in temperature on this. What if the temperature is increased? You know, when temperature is increased, generally when temperature is increased, kinetic energy increases, isn't it? Kinetic energy is directly proportional to temperature. So when temperature is increased, kinetic energy. Now when kinetic energy increases, we know that kinetic energy is equal to half mv square. So when kinetic energy is increased, when kinetic energy increases, apparent mass of electron, mass also increase. Of course, not the real mass, apparent mass of electron also increases, right? Now, when apparent mass increases, look at this, mass and specific charge, they are inversely proportional. So when mass increases, specific charge decreases. So finally, I can just tell you that the specific charge decreases. So the point to be noted is when temperature is increased, specific charge decreases. Okay. This is all about the data of electron, proton, and neutron. The fourth some important point.